Today we're going to talk about law of sines. Our essential question is, how do we use the law of sines to solve non-right triangles? First thing we're going to do is start out with what the law of sines is. Law of sines is this little situation where we have A over the sine of angle A equals B over the sine of angle B equals C over the sine of angle C. So you'll notice it's got proportional equivalencies, where A, B, and C, little a, little b, little c, are sides, and capital A, capital B, and capital C are angles of triangle ABC. And what I want you to notice on the triangle here, we typically use this for non-right triangles, and you have angles A, B, and C, and then notice that the sides that correspond to them are opposite of them. So little a is across from angle A, little b across from angle B, and little c is across from angle C. So go ahead and pause and write this down, and we'll be right back with an example. Okay, example 1 says determine side A, side B, and angle B using the law of sines. So first thing we're going to do is write down our formula, which is A over sine of A equals B over sine of B equals C over sine of C. Now we're going to plug in what we know into this setup here. First thing we're going to do is we're going to locate the ratio where we know both of the values. When you're using law of sines, you have to have one of your ratios where you know both of the values. And you always have to know at least one angle. If you don't know at least one angle, then you can't use the law of sines. So on this particular one, we know both angle C and side C. So we are definitely using C and sine of C. The other one we're going to use is the A sine of A one, because we know one of those two values. Notice for B, we don't know either one of them. We could find B very easily, but because it's a proportion that we're going to be setting up, we have to know 3 of the 4 entities. So we're going to use A over sine of A equals C over sine of C, and we are going to solve for little a. So let's go ahead and fill that in. We have A over sine of A equals C over sine C. You will only ever use 2 of these ratios at a time. You cannot use all 3 of them at the same time. Once I've written that down, now I'm going to substitute in. Little a, I don't know. Big A is 25, it goes here. Little c is 15. And big C is 110 degrees. Now that I have it set up, this is a proportion, so we're going to solve it the same way we solve all proportions. We're going to do cross products. So we're multiplying these 2 together, and we're multiplying these 2 together. So when I do that, I get sine of 110 degrees times A equals 15 times the sine of 25. My last step, to solve for little a, I'm going to divide both sides by the sine of 110. And once you do this, you would then put it in the calculator to finish solving it, making sure that, just like before, the calculator is set to degrees. If it's not, you will get the wrong answer. So we put this into the calculator, and we get that A is approximately 6.7. You're just going to put it in the calculator just like it looks. 15 times sine of 25 divided by the sine of 110. go ahead and record this, and we'll do one more example. Now that we found little a, we now have to go back and we still want to find little b and angle b. So the next thing I'm going to do, if I look at my triangle, I know that this is 110 degrees, this is 25 degrees. I now need to find angle b, and I can find angle b by subtracting angle A and angle C from 180 degrees. So I'm going to take angle A and angle C, which are 110 degrees and 25 degrees. You can add them first and then subtract, or you can just subtract them individually. And 180, take away 25, take away 110. It's 45 degrees. So angle B has a value of 45 degrees. Now that we know angle B, we can go back and use our B and C part of the law of sines, and we can figure out what little b is. And you always want to go back and reuse that initial ratio where you knew both of the values, which was the C ratio, because I don't want to use an approximation. We got A by an approximation, so I don't want to go back and use A again to find my answer. Two reasons: I might have messed it up, and second reason, because it's an approximation, and you do not want an approximation of an approximation. So I've got my values here. Let's go ahead and plug them in. C was 15 over sine of 110. And B, little b, we don't know. Big B is 45, so we're going to do the sine of 45. Once again, we're going to do our cross products, and we're going to simplify and see what we get. So go ahead and pause, see if you can do your cross products, and we'll come back with the answer. So when we did our cross multiplying, we got 15 times the sine of 45 divided by the sine of 110. We get that B is approximately 11.3. Notice that B is bigger than A. A was 6.7. And C was bigger than both of those because C had the biggest angle, B had the next biggest angle, and A had the smallest one. So it makes sense that that would be how we came up with our sines, or with our side lengths. Go ahead and finish recording, and we'll move on to our next example. Okay, example 2. We need to determine little a, side A. We also need to determine angle A and angle C, so we're finding all the missing parts. First thing we're going to do on this one is we're going to notice what we have. We have angle B given to us. We have little b given to us. And we have little c given to us. So once I have determined the parts that I have, now I'm going to go set up my proportion using law of sines. I don't have any of my a parts given to me, so I can't use that part of the law of sines, so we're going to use the b and the c parts. So from law of sines, it's a over sine of a, b over sine of b, c over sine of c, and we're going to use these two parts because these are the parts we know. So let's go plug in and see what we get. So for little b, we know that it's 10 over the sine of 48 equals little c, 7 over the sine of angle c. Now in this one, I'm having to solve for an angle. We're still going to do our cross multiplying. So if we cross multiply, we get 10 times the sine of c equals 7 times the sine of 48. We're going to divide both sides by 10. And we are left with sine of C equals 7 times the sine of 48 divided by 10. Now we have to remember how we finish solving for an angle. We have to undo the sign by doing the inverse sign on both sides. So sine to the negative 1 of 7 times sine of 48 over 10. And that's what angle C is going to be equal to. So let's put that in the calculator and see what we get. When we put that in the calculator, we get that angle C is approximately 31.3 degrees. Now that we know angle C, we can now find angle A by subtracting B and C from 180, and you can find angle A, and then you can go back and find side A by using the law of sines, which, to save time, I am not going to do. That's it for this video. There will be a second video over law of cosines, which will come out in a little bit. Thanks. Bye.